Dear children, today we are going to learn about quadratic equations. We are familiar with quadratic polynomials, linear polynomials, cubic polynomials, etc. Consider x plus 1. This is a polynomial, and the exponent of the variable of degree of this polynomial is 1. So it is called a linear polynomial. What is a quadratic polynomial? X square plus x plus 1 is a quadratic polynomial. Quadratic polynomial. Why? Because it's a degree. Degree is 2. So second degree polynomial with a non-zero coefficient. Second degree polynomial. Coefficient of the highest degree term is 1. So this term exists here. So this is a quadratic polynomial. Now x cubed plus x square plus x plus 1 is a cubic polynomial. Because its degree is 3. We are also familiar with the standard forms of linear polynomials, quadratic polynomials, cubic polynomials, etc. What is the standard form of a linear polynomial? Ax plus b, where a not equal to 0, that is coefficient of x cannot be 0. What happens if coefficient of x equal to 0? It will become a 0 degree polynomial. B alone, a number alone. A and B are real numbers, number alone. So a does not 0. A cannot be 0. This is the standard form of a linear polynomial. What will be the standard form of a quadratic polynomial? Ax square plus bx plus c, where a is not equal to 0. A cannot be 0, but b can be 0, c can be 0. What happens if a equal to 0 and b is not equal to 0? This becomes a first degree polynomial, linear polynomial, if a equal to 0. If a not equal to 0, b is equal to 0, c equal to 0, we get ax square. So a second degree term is there. So it is a quadratic polynomial. Now we are going to discuss about quadratic equations. What is a quadratic equation, or how will you change a polynomial into equation? Linear polynomial. If ax plus b equal to 0, then this becomes an equation. Polynomial equation. Ax plus b equal to 0 is an equation. It is a linear equation. We have already learned about linear equations and how to solve the most different properties. Now, let us consider this standard. Ax square plus bx plus c. If ax square plus bx plus c equal to 0, we get a quadratic equation. Or second degree equation. Quadratic equation, second degree equation. So this can be considered as the standard form of a quadratic equation. Ax square plus bx plus c equal to 0, where a is not equal to 0. A cannot be 0. What are a, b and c? A cannot be 0. A, b and c are real numbers. A cannot be 0, but A can assume any other real number. B and c are also real numbers. B can be 0, c can be 0. What happens if b is equal to 0? We get a square plus c equal to 0, where b is equal to 0. C, A and C not equal to 0. If c equal to 0, what happens? B not equal to 0. We get ax plus b equal to 0. This is also a quadratic equation. Here a not equal to 0, not equal to 0, b not equal to 0, c equal to 0. So what is the general form or standard form of a quadratic polynomial? Ax square plus bx plus c equal to 0, where a not equal to 0, a, b and c are real numbers. For example, x square plus x plus 1, x square plus 3x is equal to 0, x square plus c equal to 0, x square plus 2x equal to 0 are quadratic polynomials. Now let us see how we can frame or form or represent a given statement into the form of a quadratic equation. For example, the area of a rectangular plot is 528 square meters. The length of it is 1 meter more than its breadth. Represent this by a quadratic equation, so that we can find the length and breadth of the rectangle, length and breadth of the area of a rectangular plot. The area is given as 528 square meters. Let the second condition is the length of it is 1 meter more than the breadth. So we can choose breadth as unknown quantity, x breadth. Then what is its length? Its length is 1 meter more than the breadth. That is x plus 1. Now area equal to 528. Length into breadth is the area. That is x into x plus 1. Length into breadth equal to 528. And x into x plus 1 equal to 528. X into x square plus x into 1 x equal to 528. This can be converted into the standard form by taking or transposing 528 to the LHS. X square plus x minus 528 equal to 0 is the required quadratic equation. That is x square plus x minus 28 is the quadratic equation which represents the given statement. The product of two consecutive the product of two consecutive integers. Product of two consecutive positive integers. Positive even integers. Positive even integers. The product of two consecutive form a quadratic equation to represent this statement, so that we can find the numbers. Two consecutive positive integers. What is the first integer? It is unknown. So we have to represent it by x. If x is the first integer, so we can write it first even integer equal to x. Now, which is a consecutive positive even integer of x? Next integer, even integer, equal to x plus 2. X plus 2. Then the product of these two, x and x plus 2. X and x plus 2 is given as 80. Simplify this. X square plus 2x equal to 80. X square plus 2x minus 80 equal to 0 is the required. Another example, the product of two consecutive positive odd numbers. Consecutive positive odd numbers is 50. What are the numbers? So consecutive odd numbers. First number x. Then what is the second number? Second number again x plus 2. Two consecutive odd numbers. If the first order number is 3, second order number is 5. If the first order number is 7, second order number is 9. That is, difference between two consecutive order numbers is 2. So first order number x, then second order number x plus 2. Then product of this x into x plus 2 equal to 50. X square plus 2x equal to 15. X square plus 2x minus 15 equal to 0 is the required quadratic equation. In this way we can convert statements into quadratic equations, and thus we can find the required factors given in the question or in the statement. Here the factors required to find out are two numbers, first number and second number. So what is important is the standard in this section is the standard form of a quadratic equation and the conditions. Ax square plus bx plus c equal to 0, where a not equal to 0, b and c can be 0, a, b, c are real numbers. Now read textbook pages 70 to 73 and then do the examples 1 and 2. Also do the exercise 4.1 question numbers 1 and 2 all sub questions. Thank you.